Welcome to solverfy.
For this problem, we're going to be solving a system of linear equations, and we're going to do that through the form of writing it as a matrix and performing row operations. And so the first thing that we need to do is write this problem as a matrix. So we're going to do that by creating a matrix, and inside this matrix, we're going to put all of the coefficients of the original problem. And we're going to multiply that by all of the variables from the original problem, and that's x1, x2, and x3. And finally, we're going to use that to equal all of the answers from the original problem. And now we're going to manipulate this matrix using the row operations in order to manipulate the left side into the identity matrix and manipulate the right side into the final answers that we're looking for. So the first thing that we're going to do is take this one up here and use it to kill the 2 underneath it. And we'll do that by replacing row 2 with row 2 minus 2 row 1. And when we do that, we will have this new matrix. And I will be abbreviating the x1, x2, x3 as just x to make things a little easier to follow. And so now that we have 1, 0, 0 in this first column, we're going to get rid of the 2 in the second column. And we'll do that just how we did the last one by replacing row 2 with row 2 minus twice row 3. And when we do that, we will have this new equation. And you can see that we're doing the same operation on this right-hand side. So in this case, that meant replacing -9 with -9 plus 4, which gives us -5. So moving over here, we'll just continue the same process, except that we're in a little bit of a tricky spot because we don't have a 1 anymore. So these 1s were really, really helpful in getting rid of the 2s, but we don't have any 1s in the third column. And so in order to get a 1, we're going to use our second row operation, scaling, to scale the second row by 1/5, and that will give us a 1 in that column. And once again, we scale the answer as well, so we have a -1 where we used to have a -5. And so now we finally have a 1 in every column, and so the only thing left is we have to use the 1 in the third column to kill the 3 and the 5. So let's start with the 3. So we'll do that by doing row 1 equals row 1 minus 3 times row 2. And when we do that, we will now have a 0 in that first row. And you'll notice that we've gotten the first row now to be the first row of the identity matrix. So we're going to do the same thing and use the 1 to kill the 5. And we'll do that by doing row 3 equals row 3 minus 5 times row 2. So finally, we are almost at the identity matrix with this second to last one, but not quite. And so in order to get the identity matrix, we just have to swap rows 2 and rows 3, and that we'll do that with our final row operation interchange. So when we do that, we have the identity matrix. Hooray! And remember that when we've been writing x here, it's really x1, x2, x3, so we'll write that out this time. And when we write out our answer matrix, we can see that we've solved our system of equations, because if we perform matrix multiplication on the left, we'll have x1 plus 0x2 plus 0x3 equals 5, and then 0x1 plus x2 plus 0x3 is 3, and 0x1 plus 0x2 plus x3 is -1. And that means that x1 equals 5, x2 equals 3, and x3 equals -1. So finally, we can check our solutions to that by just starting. So we start with seeing that, yes, indeed, we did solve this. And we'll now show that this works in our original set of equations. So that for the first equation that we had, that would mean that we want 5 minus 3 times -1, or plus 3, to be 8, which indeed it is. We want 2 times 5 plus 2 times 3 plus 9 times -1 to be 7, which it is. And 3 plus 5 times -1 should be -2, which indeed it is. So this all checks out, which means that we have successfully solved our system of equations and done so using matrix operations to manipulate our original matrix into the identity matrix and our right-hand side into our solutions. Thank you.